Hi, welcome to Lectrosonics. It's kind of an opportune time. It's closed for the weekend, so I don't have anybody here right now, but let me give you a little guided tour of the facility.
This is Gordon Moore. This is the president of Lectrosonics. How are you doing, Gordon?
Hey guys, how you doing?
Well, we are absolutely wonderful because we get to take a special behind-the-scenes tour here at Lectrosonics, and I cannot wait to see it.
And it's only the scenes because it's Memorial Day weekend, everybody's home for the holidays. But we have the whole plant to ourselves now, so let's show you how we make the sausage.
Absolutely. Love to see how the sausage is made. Following you.
Follow me. All right, well, right up front, here we have our museum. We have a history of the products that Lectrosonics started with. Lectrosonics starts from the term lectern. We made big lecterns that were used in hotels and conference rooms and so on, that were amplified, had a built-in speaker, and also little portable PA systems. This is a raw unit, and this was a finished unit that were used for tour guides, like the Seattle Kingdom. And so our first wireless microphone was a low-band VHF, 31 megahertz. Now, 31 megahertz is a pretty long antenna, so, you know, a pretty long wavelength. So you need a pretty long antenna in order to capture the signal.
Yeah.
And boy, this thing was great. Got us about 30 feet of range. It was a pretty inefficient unit.
Wow, but that is a really impressive first product to have. What year was this made?
This one was about 1980. We also had a little portable guitar amplifier called the Maxi Mouse, and it was very popular in New York, New Orleans, and San Francisco. We sold about 20,000 of these in New York. All the street musicians carried them, ran on lead-acid gel cells, rechargeable, loud as Dickens, and worked great with electric guitar. Herbie Hancock did his entrance to the Grammy Awards one year carrying one on stage. So, popular little amp. A lot of people are mad at us for stopping making them, but we needed the production line for some wireless microphone. The demand was pretty high. This drawing right here is the first circuit diagram and assembly diagram for the M30 transmitter. That was the low band VHF transmitter, the 30 megahertz unit. And so it came in this cute little plastic housing. Oops. If it looks familiar to you, that's because we went out on tooling costs with Ralph Belgique at Comtech for the cost of the tooling for the molds. So he molded his products and we molded our products from the same molds way back in the early 80s. Here's the original plug-on, the M30 XLR. Then we also did a lot of installed sound equipment and portable PA. The Long Ranger was a product that helps get Lectrosonics back in track way back in the 80s. This was a portable PA system, came out in May of 1975, and it was capable of generating 130 decibels at 3 feet, and it could cover a football field. It runs on lead-acid gel cell batteries and had a built-in wireless, and we sold a ton of these to band directors and auctioneers.
I bet you did. Auctioneers would love that.
And a few SWAT teams as well. So it was kind of a fun product. And it got a lot of attention, and we sold a ton of them. Now, Lectrosonics, way back in the early 80s, was in serious trouble. It was going bankrupt. It wasn't doing very well. So a gentleman named John Arison was contracted as a consultant to come in and examine the company and report to the shareholders what was wrong with it, what needed to be done. And this is his notebook that he took all his notes on of the company. He interviewed dealers, he analyzed the costs of the products and so on. And from this notebook, he came up with a little plan for the company. And they decided they liked it so much they hired him to run it. And he was the one who said wireless was the future for Lectrosonics. And he literally saved the company. So that is the document that turned Lectrosonics around, and that was 1981. Wow. So we also do installed sound equipment. We did automatic microphone mixers that are used in literally thousands of courtrooms around the United States. I think I've been in more courtrooms than a habitual criminal These are the Freedom mics. They're an early VHF unit. These actually are what got us on the map. The DR185 actually uses pipe couplings, 3/4 inch pipe couplings that we machined to become resonators for filters. And it was the first 6 helical resonator front end available in a wireless microphone. And this was a robust radio. It was the design from which the CR185 was derived.
How many awards would you say Lectrosonics has earned over the years?
Ooh, no one's ever asked me that. My guess would be 150, 15 times 30. Well, that's not 150. That's
a lot more.
It's a lot of them.
That's a lot.
We had a lot of awards. Yeah, a lot of trade show awards. That was, the biggies, of course, is the Academy Award that up there. We had 3 engineers honored with that. That was really a high point for us. So basically down this hallway is our sales department and so on. And this is Carl Winkler's office. He keeps a few hats. The higher up you go in the company, the smaller your office gets. So this is my office.
This is your office?
This is my office.
That's amazing.
Yeah, we don't, I probably do the least around here, so I get the smallest space.
And you have new toys, it looks like.
We do have some new toys.
I need to know if there's anything I need to censor.
Yes, there is. I'll tell you, but yeah, you need to censor that. You can leave it in the picture. We just won't discuss it. You'll see a lot of posters around the plant. And so what the posters are is any production that uses our gear. And of course, we give a preference to those that have been nominated and of course the winners for awards such as BAFTA, CAS, and the Academy Award. And there's a lot of them all around. So Walking Dead, of course, is one of numerous Emmys. This is the Skunk Works.
The Skunk Works?
This is where the products get developed. This is where new product development occurs. So, for example, this engineer here is working on a new toy, and I think that's it partially dissected on top of that analyzer over there. And so we've got a number of, in fact, quite a few new projects in the works. This engineer here, he's an RF engineer. You can tell by his bench, he's just got a tremendous amount of RF test equipment. And he's the one who developed this as Derek's office, and he is the one who developed the DCR822, the Duet, the Quadra, most of our digital receivers. And so he, of course, now is working on a hot new product that is cooking along, making big progress. So we have a new mechanical engineer. He just started. This is his office temporarily, but the one he's replacing just retired. So he's going to get the office that has the...
That's why he doesn't have all the GAC all around just yet.
Not yet, but we'll show you the GAC here. So we'll head back that way. So here's where our mechanical engineer was before retirement. And even has his truck still up on the screen. So, but Brian Kurowski was our engineer, and you'll see postings about his retirement. But he designed just about everything over the last 18 years. He did all the mechanical designs. You know, there was another mechanical engineer, and the two of them together accounted for literally all the mechanical work. He was the one who came up with the new curved front panel with buttons for the DCR822. That was his baby. These guys develop all the new products. This is where we develop new ideas, new products. There's a lot of ideas getting tossed around all the time, and new product today takes a lot. In the old days when I first started here, you had an electrical engineer and you had a mechanical engineer. Now, today on any given product, you got your electronics, you got your RF engineer, you got your audio engineer, you've got your embedded code engineer, you've got your firmware and then software and mechanical. So now it takes a much bigger team, and there are a lot more sophisticated products than they were back when I first started here. That was 33 years ago. This area here is the production administration side. This is where the offices are for the production people who keep the production line running and cooking. So we just redid this area, and then our purchasing is these two people sitting right here plus the office behind you. Vice President of Production works here. And you could tell that Wes is the vice president because his office is quite a bit larger than mine.
It also has a C++ and Python and everything else. But
oh, yeah. And then our purchasing agent works in this office. So here's where we have purchasing going on. She's the senior buyer, and then she has 2 other buyers that work with her. So they have to buy a lot of parts. So let me show you where we keep the parts. So back here is our stock room. We currently have an inventory of about 11,000 parts. 7,000 of those are currently active parts, the parts that we use in current products. The other parts are stuff we need for, or used to need for, the older products. And since we support stuff as long as we can get parts for it, we have a lot of inventory here that is there just simply to support the legacy products. So when a guy's got a 20-year-old transmitter and sends it in and it needs a new crystal, if we have that crystal, or if we can get that crystal, we can still support the part. We have a long history of trying to maintain products way beyond what most companies would. So it's not unusual for us to get repairs in that are looking for, that are for products that are 15, 20 years old. It's a very common thing. So we keep all the inventory here. And back over here, when they're getting ready to produce something, we'll go over here. They get what are called travelers. This is a traveler, a job traveler. This is how we build the product. And it's a detailed instruction set that shows all the parts that are required for the product, and then a detailed step-by-step assembly instruction that covers every action that is required to build the product, so that when they're putting it together, they have no variance from one batch to the next. Everything is documented. I spend a lot of my time okaying what is called an engineering change order, an ECO. ECOs could be a change in instructions on a traveler. An ECO could be a replacement of a part for another part. It can be a change in a dimension. It can be a change in the packaging. Any changes go on an ECO. Nothing, even the manuals get changed with an ECO, because we want to keep track of what changed and when. So these job travelers basically go around. So this is for the M2C, and this is the whole kit, and that will travel with the units as they go into assembly and start getting built. We also burn in a lot of equipment just to make sure. We had some issues with the display for the D-squared some time ago, so now we're burning them in and making sure. The supplier had an issue with the production run, but we take care of these things. If something goes, you can't be perfect. What you can do is be perfect in your response and take care of it, or try to be. So over here is laser engraving. All our products get laser engraved. So these are basically Windows printers that use a laser. So the product gets mounted into these jigs, and then the laser just moves back and forth on the axis and burns in the instructions. So a perfect example of that is this unit right here. If you ask who the #1 sound mixer in the United States is, you get a lot of volunteers.
Yes, you do.
But in China, specifically the People's Republic of China on the mainland, the state designates who's #1. And #1 sound mixer in China was using our gear. So we had our dealer send us his signature, and we custom made housings for him. Cool. Because he did some very nice ads for us to be run in some Chinese magazines. So we put his signature on the unit.
That's awesome.
It was very cool. He was very surprised.
And I'm sure humbled too.
These were the test housings that we tested it before we set them up.
That's awesome.
And as you can see, our laser guy is a lover of aircraft.
So do you buy a lot of stock for parts? Do you buy a lot of that in advance and stock them in order to get a better deal? Or do you buy them in smaller batches and use them and then move on?
The real question is, are we doing just in time? And the answer is no. Just in time means always late. We actually carry a heavy inventory of parts because when there are parts problems, it's nice to have a 6-month supply to back you up.
Yeah.
And we've had issues where, for example, right now there's a current parts crisis partly caused by a fire in Japan for AKM parts, and those parts are used by everybody. I mean, literally everybody. And we had enough inventory in stock to cover us while we redesigned the products for different parts so that we could continue with production. But if we had been just in time, it would have drawn us to a complete stop. So no, we don't believe in just-in-time manufacturing. We carry a fairly heavy inventory, and that's these parts over here. We keep all our parts in this area, or most of them, and the ones that start, for example, with P, those are plastic parts that we tend to make ourselves. We have our own mold injection capabilities for small parts, and so we do small things like housing clips and so on. And we also keep all our surface mount parts back here. We keep it's a wide range, connectors, everything. Basically, it's all right here. We're a vertical manufacturer, so we try to do as much in-house as we possibly can. Now, located off to this side of the aisle is finished goods. So you can see in this section right here, we've got our auto mixers, equalizers, signal processors that are used in courtrooms, conference rooms, boardrooms. And this is a line that is about to expire because of parts issues. They're no longer making the Shark processors that are in these. We still have enough to go about 4 more years, and we're continuing with that. So these are products we make for them. And then over in this area is our shipping department and our finished goods. So we have all of our finished goods here. So you can see here's some Venue 2 receivers, modules. We've got a bunch of UCR 411As. We have UCR 100s. We have a lot of 411As still in 22, 23. They're slowly going down. SRCs are kept here. So the finished goods, about half of this inventory or more right now is already sold. It's already committed to orders, and what it's waiting for is, since we sell systems, you may have the receiver on the shelf, but the transmitter's still in production. So when they get together and get married up, then off they go to the dealer. So we do all of our own packing, and we try to use recyclable packing as much as we can. Even the peanuts that we use are biodegradable.
Do you try to locally source as much stuff as you can to try to help the local economy?
We do, but there's a lot of things that just simply are not available in New Mexico. For example, one thing that we're working with a local plating company. The coating that we use on our transmitters, the ebony black, is very difficult to do, and there's only 2 places in the United States to do it, one up in Colorado and one out in New England. And we are working now with a local plating plant that we've been working with a long time, and we are working with them to get them up and running so that we can do it here. So we're real excited about that because it's nice to get it so we can just load it in a truck, and take it down and have them take care of the plating here. Shipping department likes to, they like to go electro spotting, and they catch something, they'll print it out and post it up on the wall. Funny story about this one right here. She is not in New Mexico anymore, but she was a local anchor. And someone spotted her Lectrosonics on her ankle and thought she was wearing an ankle bracelet and wanted to know what she, and started a rumor that she was in for a DWI. So she did a whole thing about how, no, this is just my IFB and my transmitter. Welcome to Surface Mount. This is where we put the tiny parts on the boards. So it's a multi-staged process. And the first process is to take a bare circuit board and put the solder on it. And the solder has to go on in a very precise fashion. And in the past, we were using a solder mask. It was like screen printing. It's a stainless steel mask that would be laid on top of the board, and then the solder would be squeegeed on using this ecra right over here. This would spread the solder, but just like screen printing a t-shirt. But we've gone upscale on that now, and now we take the bare circuit boards like this, and we put them into this unit. This is basically the equivalent of an inkjet printer that squirts solder in highly precise amounts. It is amazingly fast. We're doing about 90% of all our boards now with it. It dropped our failure rate on boards out of surface mount dramatically, absolutely dramatically, because it is so precise. With this, not only can we specify the size of the pad that takes the solder, but we can also specify how thick the solder is, because some parts need a thin film, others need a thicker blob, which you cannot do when you're doing screen printing. It's all the same thickness. But with this unit, it goes through and it puts down precise levels of solder as well as size, and it goes back with the camera and double checks its work before it spits the board out. And it fixes itself. And it's amazingly fast to watch. So as this then puts the solder on, then after that, it goes to these units here. These are the surface mount machines. And what they do is there are 6 vacuum heads right here that pick the parts up from these reels and puts them on the board. And they can go at about 10,000 parts an hour is their top speed. So you can pack a board pretty quick. When I first started at Lectrosonics, I ran production with another person, Chris Butler, and we were doing through-hole boards. And we had this one board for our auto mixer. And a run of 50 of those took one of the assemblers about 2 weeks to build through-hole. When we went over to surface mount, it took a morning to build 50 boards. So the efficiency of these things is amazing. Yeah. Setup time oftentimes is longer than the actual time it takes to stuff all the boards. But the accuracy is incredible. So we have 2 of these units, and so we can start a board here and then take it over here, and then the combined total of the reel capacity is enough to have all the parts you need for that particular board. Then we also have this MyData 19 over here, and with this one, the head is located right here and flies back and forth. And the MyData picks up, and the board assembly itself goes in here, mounted on magnets, and then parts are put down. And as you can see, it can hold a lot of reels. This is an example of the parts that we can put down, and that is the 0402 part, which is 40 thousandths by 20 thousandths of an inch. And these machines put them down at an unbelievable pace. And it also does these BGA type of chips, ball grid array. And you have to align precisely with those dots for the unit to work properly on the board. After it's gone through the surface mount machines, the boards are taken over here. And if this looks familiar, it looks a lot like a Quiznos sub oven. That's kind of what it is. It's a multi-zoned oven that will then melt the solder, and it has several zones inside so you can warm it up so you don't warp the board too much, you don't cause the parts to get too hot, and you want the solder to melt. And we run it through the boards, and then basically it comes out the other end and it's ready to go into QC.
So these boards here,
yes,
those are going to be going into what equipment? What are those parts for?
Good question. D-squareds. And look at the size of this ball grid array right here. And that printer will put the paste exactly on those gold dots.
When you automated this, because you obviously went at some point from a person doing it to a machine, did a lot of the people that were doing the soldering manually configure and then continue to transition into new roles still working in it? Or?
Yeah, the majority of them, then we still have through-hole production. We still have parts that have to be hand assembled. So what that meant is instead of them putting 200 parts on a board, they were only putting 5 or 10, but they could do a lot more. So as our volume grew, we still were hiring more people, but we didn't have to have as many people to do a tenfold increase in boards. When I started here, if we sold 25 CR185s in a month, that was considered a pretty hot month, 25 for the month. And then they caught on, and suddenly we had to build 250 a month. And oh my gosh, no one ever lost a job to the automation. What they got was a new, better job because we had to train them. We had to take them off the line, get them trained in operating this equipment, and make them competent in these kind of technologies. So it was it's a big transition. We have one employee here. She started in I believe, just doing some basic assembly. And now, after 40 years on the job, she is building prototypes for the engineering department. We're her only employer. This is surface mount quality control. This is where some of the handwork that needs to be done gets done. But most importantly, each board, and every board, not just some boards, but every board, gets sat down under a microscope by the QC operator, and they go through the final board and look for problems and try to eliminate them before they go to test.
I imagine it's also easier to handle when it's on a board before it is punched out and everything.
Exactly. And in some cases, they'll also then in this area add the fences for the RF protection, like this. These are RF shields that will be mounted onto the board after it's gone through inspection. So we have 2 stations that do this work, and an amazing amount of stuff goes through these 2. And they've been doing it for a long time. Just amazes me how good they are.
They double check the machines.
They double check the machines. And on our QC processes, everything gets checked a minimum of twice. The more sophisticated products can have 16 or more QC stages along the way when you count all the individual boards, all the individual processes. We do a lot of QC, and we don't do spot checking. It is every board, every unit. After we've gone through surface mount and surface mount inspection, the boards are now ready for production quality control. In surface mount inspection, they're looking for visual problems. Parts that have tombstoned on the port, parts that have skewed and not sitting square on their pads, parts that are missing or not sitting in the correct direction, a diode in the wrong direction, things like that. Things you can visually see. After visual inspection becomes the electronics production testing. That's what this department is for. So we have scattered around the plant 4 Faraday cages that are used for testing receivers in an RF-free environment. We can set 2 people in here, but because of COVID, we're now just doing 1 person per cage. But when you close the door, a radio won't work, your cell phone won't work.
That's a beast of a door, Gordon.
It's a beast of a door, and you see the little copper tongues along the edge. Those copper tongues help seal it and ground it, so it thoroughly keeps you grounded. So we do all of our production testing for receivers in this area. Then, in this area, we have our individual testing stations. So every bench has equipment specific to the job for which that bench is designed. Some products go some places, some go others. So this is basically where they get all their QC testing. So this guy does a lot of transmitter testing. So he gets some spectrum analyzers. Setting up a production test bench is about an $80,000 to $100,000 commitment. So we run 2 shifts in this department, as we do in surface mount, and they hot swap their benches here. So
how many total benches do you have?
I don't know. I don't know. I'd have to count. It's a bunch. There's some in Faraday cages, some that are out here. Here, for example, are units that are ready to be aligned. These are IFB receivers, IFB R1Bs, that are ready to be aligned in the cage. So there's the Traveler, And the units themselves, they'll get tested, they'll get calibrated, and then they'll get canned. So it goes from here over to the final line for canning.
And canning is
Putting them
inside the case.
Putting them inside a case. So this is where we do all the final mechanical assembly. And so shields will be soldered into place, control panels will be set up. Eventually it'll get into a housing. Now this may be a subassembly where this is for an M2T, it looks like, or what is it, MT? I'm not sure. But this will get assembled and then very carefully tested as an assembled board and then come back for the case housing. So this is getting multiple QC steps and tests. So here we have some receivers, SMDWBs, getting ready, and here's the circuit boards. So we run 2 shifts here as well, and they're scattered so that they're not close to each other because of the COVID realignments. So more units getting ready to go.
Now, what was different before COVID regarding spacing? It looks like each desk still required a lot of space for all the different tools and everything.
Yes, they were well spaced to begin with. But before COVID, we had the morning shift at that end and the evening shift at this end. And now what we've done is we've scattered them so that they're spread farther apart morning and evening. So they're just a little farther apart. And we've been very fortunate. We haven't had any major outbreaks during this whole thing. And we got back up and running by about August last year.
That's good. That's right. As production was starting back up too.
Exactly. Yeah. So we were able to keep everybody working. We were able to keep everybody paid. That was important to me. And we've got everybody still with us pretty much. So cannot complain. Here's IFBT4s getting built. These tubes are for guides for cutting the antennas to the right length.
Gotcha. So you just put it right on there and then you cut.
Slide it over, snip, put a cap on, keep going.
Everything is coded. You have to know so many little parts and everything.
For example, the screws. This is the 28710 screw.
You probably have somebody employed whose sole responsibility is to replenish these as needed, who has to know exactly where everything is and everything goes.
Actually, the duty is spread out among the shift supervisors. And so everybody knows where to go get it, but when they go get it, they have to go check it out. There's a checkout form so we can track the inventory.
You have different times.
Actually, we don't. Somebody set all those clocks at the same time.
So all the different clocks.
They're all set at the same time. I've forgotten why that is, and it's become kind of a running joke around here. Okay, so you've seen now how we put parts on a board. You've seen how we test the boards. You've seen where we assemble the boards for the final hand assembly stuff.
And now you're taking me to the free samples?
And now no. What? That's a contradiction in terms. We're going to go and see how the cases are made. This is where we make the housings. This is our machine shop. It's a separate building. And our biggest piece of equipment is this unit right over here. It starts here and ends here. And it's a laser that cuts sheet metal. And you can see that they've been cutting some pieces out of this sheet of stainless steel here. So the laser itself, the head is in this assembly, and I don't think I've got the key to unlock this, but there's a laser inside here, and we got great footage for you. But this is a 2 kilowatt laser that's capable of cutting some pretty thick steel. We use it to cut all of our sheet metal for our housings. So all that cutting is done in-house. Then it goes, and this is the laser itself. This is the laser itself, and it's transmitted via this fiber optic cable up into the housing. That is just the mechanical assembly to move the head to get the laser where it needs to go. But this is what generates the laser beam.
The fiber optic tube?
And it's a fiber optics, yeah. And that's the cooler for it. And we need to use nitrogen to prevent oxidation while it's cutting. So we go through a lot of nitrogen gas. We're eventually going to buy a nitrogen generator and just pull the nitrogen out of the air. But right now we buy the gas and then handle it. So you can see the cooling vents here. Those flat cut metal pieces come here to this CNC brake, which bends the metal to precise dimensions.
So there's stops here that they would put a piece of metal in, press until it stops.
Right.
And then release and move it to the next stop and then do the same thing.
And they trigger it with that foot pedal down there. So with that, we can make housings like these. So that started out as a flat sheet of aluminum and now is precisely cut and bent to dimension. This is Machine Alley. This is all of our machines at our CNC mills that are used to cut the metal to the precise dimensions that we require. We use a lot of billet aluminum, so we can convert a piece that looks like this to something with a cutout for the panel. Now that's going to get more cutting out on the other side. This is just one of many operations this will go through. And we have one operator who moves back and forth between these two machines. He'll load this one up, get it running, hit the start button, and then come over and load this one up and get it running. And by the time it's up and running, this one's ready to go for a reload, and he changes out the parts. So he moves back and forth between the machines. So the Fanuc RoboBuild drill here, this holds 21 different bits. So you can have 21 different cutters in it and conduct a whole lot of operations without any breaks. This has a rotating table. This table here rotates. So you place parts in here, then hit the button, and it rotates around, and an operation has occurred, and while it's operating on the other side of the screen, you're loading the next part in. So it just keeps going like this and pounding out parts. And this is my favorite machine. This is our Moriseki. This is known as a lights out multi-axis mill. And it's making the little thumb screws to go on the bottom of the transmitters. And it gets loaded up with stock aluminum. This is the bit changer. It changes bits on this head right here. And then inside here, we have a robotic head. You can see a representation of it on the screen. The robotic head then is making changes and cuts in there. And then it'll pass the part over to the other head, which will rotate up, and then it can complete the operation. And it's called the lights out machine because, as you witnessed, when we came in, the lights were out. We load it with material, load the program, hit the start button, turn out the lights, and go home. And then it pounds out parts the entire time. See now, see it's changing heads. The cutting fluid is at nearly 1,000 psi, so it can flush the chips out because this thing cuts really fast. You can see it spraying the coolant here. And now there goes the head changing bits. So here's our billet aluminum cut to the dimensions we need so we can start cutting a final product out of it. So buried in this somewhere is a body pack transmitter. We just cut away all the aluminum that isn't. These are tumblers that we use to take the rough edges off the machined aluminum. So we put all the parts in here. And it gives the parts a finish that isn't quite as shiny, and it can take the paint or the anodizing of the plating much better, and it takes all the burrs off and just cleans it up without changing it dimensionally. This is our plastic mold injector. So we can make our own, well, this is a machined aluminum part here. Here we go. So these are parts for our handheld microphones that have been mold injected, and they'll be trimmed, cut out. You know, we got a guy that sits here all day with a knife and cuts away at it. Then we do other hand operations here. We got some presses for pressing in rivets and so on. So here's all kinds of parts that we have. This is a called a press fit thread, so we can just smash it into the aluminum and it'll give it a locking connector. And lots of parts in process. Battery doors, everything. This is a CNC cutoff saw. We'll take a long bar of aluminum and set it on here and lock it into place, and then it'll sit there and make precise cuts and just chop through it and give us those short blocks like you saw over there. Mechanical assembly is done in this area. All the battery doors, all the cases, all the housings get hand built right here. So here and the other location. Sometimes we'll have 2 or 3 people back here, typically 2. It's amazing how much they pound out. So here's our recyclables. We fill these up a couple of times a month. We recycle circuit boards, we recycle aluminum, brass, steel, basically everything. So it gets picked up twice a week and carted off. We get reimbursed for it at scrap metal prices. And eventually it gets melted down and might even make its way back here again. And this is our bar stock where we keep all of the bar stock. Now some of these are custom extrusions. You recognize a plug-on transmitter housing in the rough. Yep. And there's a die that's back at the factory, and they just squeeze the aluminum through it. We pay for the die and they just keep it there, and they make all of these different extrusions. There's a PDR. Yep.
I recognize some of these shapes instantly, and others I'm not so sure about.
And others are just standard stock, you know, regular size material that we might use for prototypes, or it just works well for what we do. We also recycle all the machine oil from the CNC mills. So nothing gets flushed down the drain. In fact, our biggest use of water is bathrooms. We don't use much water in the production at all. The tumbler back there where it tumbles the parts, that takes water. The rest of this does not. And all of this oil is recycled. It is sent back, cleaned up, and comes back to us. We do use a little power. It's a lot of power. And these offices here are industrial engineering. These are the people who document all those engineering change orders and changes in the products and so on. So they do all the quality assurance processes. Again, if you make any change, if you change the specification on a QC process from -3 to -4 dBU, there's an ECO to document that change. And these are the folks who then put that change into the system and make sure it goes into all the applicable documents.
Only Gordon would carry Allen keys around with him.
I've got your key. You got a good point there. This is the customer service department. This is the other part of the machine shop. It's actually a new building that was built on. So the products come in here, get checked in. After they're repaired, they go to the other side of the aisle and get checked out. You can see a whole bunch of repairs just about ready to go out the door over there. All tracked and international, domestic, and of course packing material for all of them. So this is the customer service department. This area here is rework. What we do when we get a unit in for repair is it goes to rework first, and we upgrade the board with all known ECOs. So if we found a certain value capacitor did a better job, we take care of that. We do all of the upgrades first, then it goes for diagnostics and repair, because a lot of times the upgrades will take care of it. And in other cases, they'll spot something that's a simple thing. Oh, look, a solder pad lifted, let's fix that. But then it goes to repair and gets double checked, QC'd, or diagnosed and repaired and then sent back. So we run 2 shifts in here and hot swap the benches. And this is another one of our Faraday cages just for repair. So we have 4 of these. We have a 5th Faraday cage, but that's where we keep our server farm. All of our computers are kept in there and diagnosed and isolated. Okay. So we keep our own separate inventory for repair here. And if they need to get something from downstairs, they run down and sign it out. We keep track of it all. So this is where the customer service reps work. And each one of them gets a pretty big workspace.
Yeah.
As we promote them, we'll shrink their space. And yeah, this is where we do the fixing. So repair authorizations, invoicing, everything is handled in this area here. Cindy and Gerald occupy those offices.
Let me ask you about the manuals. Do you print your own, or do you
We do. I'll show you the print shop. Okay. We actually have a full-blown print capacity.
And print your own manuals.
We print all our own manuals and literature. We do everything we can possibly do here at the factory. And so one of the other things is prints. We print all our own manuals. We print all of our own data sheets. The only thing we don't print is the catalog itself. But other things, the larger things, we even do banners, large posters. So we have a full print shop capability, complete with a power cutter, 2 different color printers, and a large printer. And these work centers we replace after 2 million copies. This is the 3rd one.
How often does it take you? How often do you go through 2 million copies, though?
It typically is 4 to 5 years. We used to print, but now doing it in-house, it's so much more efficient for us. So when we get a production run into the shipping department, they'll come up and have the manuals printed for that run. The other advantage is we can make changes, corrections. You guys catch a mistake, which you guys do, then we get them fixed and we make a correction in the manual. So it gives us a lot of flexibility. We do so many copies that we are officially a print center and buy all our materials wholesale. So this is the front office, basically, where basically the most tomfoolery goes along. We have our rubber required chicken. And we also have these bells. The bells are for making note of hitting sales numbers. The door to the production line is right outside this department, so they can hear these bells. And it's a big morale builder when they hear the bells. So we have one bell that indicates one level of sales, and then when you double that, you get a larger, and when you double that again, we have the dong. So we have a ding, a clang, and a dong, and it's bell math. And so we'll ring the bells, and in the back, the people on the production line are dadding it up in their heads going, oh, that might mean overtime. And so it's a big morale builder, and people have a lot of fun with it.
That's awesome.
We used to have a hammer for the big bell, but we had this one guy that just would whack it so hard he was causing hearing damage. So we took the hammer away. So everybody has to learn bell method.
And how far does that travel?
Basically, they hear it all the way through the production line, the final assembly area, and production test. Surface mount can't hear it. We can't do it to the machine shop. Many, many years ago, we decided we would let the machine shop participate. So we used the paging system and held the phone up to it while we hit the big bell. And someone in the machine shop heard the bell, thought it was a machine alarm, and hit the scram button. We have a big button up there that shuts the entire machine shop down so that no one gets hurt. And so he hit the scram button and wrecked about 5 jobs that were in the works. So we don't do that anymore. Well, there you have it. Thank you for coming to Lectrosonics. I hope you enjoyed the tour. Alan and I had a great time, and I think you get a little better idea of what we do here.
Have a question you'd like answered or want to add something? Be sure to write it in the comment section down below. You can also make a suggestion for future topics of discussion. Again, comment section down below, or you can email me at soundspeeds@yahoo.com. Be sure to subscribe and turn on notifications so you won't miss out on future sound advice.